How are you, my dear learners? I promised you that I'll start solving the questions according to the way I have compiled my documents. I compiled grade 11 questions extracted from ECZ past papers from 2013 to 2022. I did the same for other grades, that is 10 and 12. So in this video today, I'll start with answering questions from the documents I prepared for grade 11. So I introduced this syllabus to you, and I promised that I am not going to forget those who are doing Cambridge. You also need to just have patience. I am going to do something for you. So I am not going to waste time, my dear learners. There you are able to see that grade 11 questions from 2013 to 2022 ECZ past papers. In 2013 academic year, ECZ examination, we have a question from section B. Question 1 reads, the table below shows the properties of an alkali, an acid, and a salt solution. The question coming from the topic acid, bases, and salts. Meaning, looking at how we are going to answer this question is a reminder that you need to study the topic, complete the table. You need to analyze the question. So we are having the column where we are having the type of solutions used. We have one which is not given to us, hydrochloric acid, sodium chloride. Hydrochloric acid is actually an acid, sodium chloride is a salt. We have a column of approximate pH, not given. Here they have given us 7. Ion present, we have sodium ion and hydroxide ion, not given. So what are you going to do? You analyze the question and then you answer. Here they have given you the ion present. The ion present in this solution which is not given, we have sodium ion and hydroxide ion, and this is definitely an alkali. Therefore, the name of the solution is just the matter of combining the two ions, which will give us sodium hydroxide. So we are going to say sodium hydroxide is the answer. I am going to give you the chemical formula here because of limited space, and I'll name there because here we are naming. So we are going to say sodium hydroxide. That's the answer. Where are we getting the answer? From the ions given. Here we are going to get our answers from what we have here. We have an acid. This acid, hydrochloric acid, is a strong acid, and it has the pH of about 1.0. It's a strong acid. Now, from the way the hydro, just know that we have hydrogen, and the chloric is coming from a group 7 element, chlorine. So it will be an acid which is going to be formed between hydrogen and chlorine, and this acid is known as hydrochloric acid. And in every acid, we have hydrogen ion as the only positively charged ion. In this case, we know that there must be hydrogen positive, comma, we need also to have a chloric part coming from a chloride, which is like this, negative. Very important. The other part we have been given sodium chloride. Sodium is coming from a metallic part, and a chloride from an halogen, or the halogen from group 7. Therefore, we are going to say the pH is given. Sodium, when it is ionized, it forms a positive, and then a chloride, again, it's a negative. This is very simple, my dear learners. Find time to go through acid, base, and salts. We go to B. Name the two solutions from the table which, when mixed together, form a solution of sodium chloride. Two solutions from the table, not from anywhere, from the table. The challenge is that some of you guys, you fail to analyze questions. So the answers you should come up with should come from where? The table. The salt which is being prepared is in solution form, and it is sodium chloride. Now look at the table. When you look at sodium chloride, it is having the pH of 7, meaning this is actually a neutral salt, a normal salt. And we prepare sodium chloride by titration, and the reaction is known as neutralization. Now, in this reaction, we use an alkali and an acid. In this compound, sodium chloride, we have sodium. This sodium will come from the base because we have sodium in the ions. And a chloride is going to come from hydrochloric acid because we have a chloride in hydrochloric acid. Therefore, we are going to say the reagents are sodium hydroxide and hydrochloric acid from the table. So we have what we named there and what we have there. Very important. We go to question 2 from 2013 paper. Define relative molecular mass. Relative molecular mass is actually the sum of relative atomic masses in a given compound. This is more concept, guys. Stoichiometry and more concept. Now we are saying relative, meaning we are trying to find the ratio of atoms present in a molecular compound of a chemical substance. Now we are saying when we find the total masses of atoms involved in the formation of the compound, provided it's a ratio, we are going to say it is a relative, and therefore the answer is going to have no units. In this case, it's just a matter of defining the relative molecular mass, and there you are going to get your 1 mark. Question 2b. Potassium carbonate react with dilute sulfuric acid to form potassium sulfate, carbon dioxide, and water. Construct a balanced chemical equation including state symbols for the reaction. So here we are combining concepts. We understand that potassium carbonate is a salt, and the chemical formula, you need to be careful when you are presenting chemical formula, guys. So we have potassium carbonate, K capital letter. The valence of a carbonate is 2, so we are going to have that. This will be used in solid state, and I'm going to explain why. Even if potassium carbonate, it is used as a solid in this case. So plus, it is reacting with sulfuric acid, a strong acid, but it is in dilute state. So this is in aqueous state. We are going to have potassium sulfate in aqueous state, plus we are going to have carbon dioxide in gaseous state, plus water in liquid state. What are we going to do next? We are saying, the question is saying with balance. So you need to check at the end of, so you check the equation. Now, if the equation is balanced, you will see that the number of each atom involved in the production of the product on the reactant side should be equal to the number of atoms on the product side. So we check now. Potassium, we have 2 atoms there. Carbonate, we can balance the radicals as radicals. So carbonate, we have 1, and the carbonate here gave us carbon dioxide and water. So we have, when we combine oxygen from water plus carbon dioxide, we are going to have 3 oxygen atoms, which will be equal. Even carbon will be equal. Sulfate, we have 1 sulfate. We also have 1 sulfate there. Hydrogen, we have 2, and here we have 2. Meaning this equation is balanced. Therefore, we are going to tell the examiner, we are not going to leave it like that. You need to give them the statement so that you show them that you checked the equation and it was found to have been already balanced. So now you are going to say equation balanced by inspection. Here you are going to have your mark. You are also going to have your mark there. Very important. Now, I told you that I am going to give you a reason why potassium carbonate is used in solid state. Our main goal here is to neutralize this acid so that we can form this salt. Now, when we use this substance in aqueous state, it will be very difficult as for us to observe clearly that the reaction is over. Okay? So, I am explaining this so that you know the purpose. So, if we wanted to neutralize this substance completely, we are supposed to use a solid substance so that when it completely neutralizes an acid, it will stop dissolving. When it stops dissolving, that's when we are going to know that now the reaction is over. Provided potassium carbonate continue to dissolve, it means the reaction is still taking place. But when it stops dissolving, since it is in solid state, we are going to know that the reaction is over. That's the reason why potassium carbonate is used in solid state. But sometimes it can be in aqueous state since it is a soluble salt. Interesting. Calculate the mass of potassium sulfate produced when 2 grams of potassium carbonate react with an excess of dilute sulfuric acid. My dear learners, here you need to understand me. This question is demanding us to calculate the mass of potassium sulfate produced when 2.0 grams of potassium carbonate react with excess dilute sulfuric acid. In this equation, they have given us a limiting reagent and a reagent in excess. And the limiting reagent in this case is potassium carbonate. Now, under more concept, we use the limiting reagent to calculate the amount of the product formed from the reaction. When you use the reagent in excess, just know that you are going to fail that question. And the reason is simple. A limiting reagent is going to determine the amount of the product that are going to be formed from the reaction. Because once a limiting reagent is completely used, it means the reaction is going to stop. And when the reaction stops, that marks the end point of the chemical reaction. So for us to calculate the true amount of the product in terms of mass formed from the chemical reaction, remember to use a limiting reagent. Very important. So now, this question will be calculated from the chemical equation. And I am going to use my board. Remember, when we go back here, we are interested in potassium sulfate and the potassium carbonate. So we are going to form a relationship. Our relationship, since we are going to be using more ratio, we are going to say potassium carbonate, which is our limiting reagent, will determine the amount of the products which is going to be formed. In this case, we are interested in potassium sulfate. The ratio itself will help us to calculate the amount in mass of potassium sulfate formed. Now, remember that the mass of potassium carbonate used was 2.0 grams. And we are looking for the mass of potassium sulfate. We'll put X. We are going to use what we have to get what we want. We have mass. Therefore, we are going to use mass ratio. Now, how do we convert this 1 mole of potassium carbonate and this 1 mole of potassium sulfate into mass? The only thing you can do here is to calculate the molar mass. Now, when you calculate the molar mass of potassium carbonate, you will find that the value will be 138 grams per mole. Now, we are going to convert this to mass by saying mass equals number of moles times molar mass. Mass equals Here, the number, when we balanced, we didn't put any number as a coefficient in that equation, meaning we just have one more. So we are going to say 1 more times the molar mass, which is 138 grams per mole. More and more will go, and the mass will be 138 grams. This is the mass. It means you have converted your molar mass of potassium carbonate to mass. Now this mass is the one we are going to put here. 138 grams. 2. You do the same this side. The same procedure we have used here. And your final answer will be, it should be 174 grams per mole. Okay? Now, what are you going to do here? We are going to cross the multiplication there. You will find that we are going to have 138 grams dot x equals 2 times 134. You will find that the value will be 348 grams squared. We are looking for x, so you are going to say over 138 grams over 138 grams. Therefore, we are going to say the value of x equals G and G will go, G and 2 will go, and then we are going to remain with what? Our final answer, which will be 2.52 grams. This gram is for the amount of potassium sulfate. This is how we are supposed to move. Very important. If you are used to moles, you can convert 2 grams to moles so that you can use more ratio. You find the number of moles of potassium sulfate formed, and then you convert those number of moles to mass. You arrive at the same answer. Thank you so much. Going forward, what is the identity test of gas produced in the reaction above? My dear learners, we had a gas which was carbon dioxide. How do we test that indeed from this chemical equation the gas which is being given out is carbon dioxide? Carbon dioxide is the only gas which is able to turn lime water milky. So when we use lime water and we bubble this gas into the same lime water, it will cause the color of lime water to change from colorless to milky. So we are saying it turns lime water milky with a Y. Don't forget a Y, guys, at the end. That Y is very important because it indicates that what is going to be formed is not a pure milk, the one we can even drink, no, but it will just resemble the color of milk, the way it looks. So it will be looking like milk, but it is not necessarily milk. So that's the reason why the Y at the end is very important. Interesting. We go to question number 3 of 2013 paper. Question number 1. Copper 2 sulfate is a soluble salt prepared by using sulfuric acid as one of the starting materials. Define a salt. So this topic in 2013 came in abundance. So what is a salt, guys? A salt is a chemical substance consists of a metal or ammonium ion and a non-metal from an acid. This is a very good definition of a salt. So we are saying a salt is a chemical substance consists of a metal or ammonium and a non-metal from an acid. Every time a non-metallic part of every salt will come from an acid, and a metallic part will come from a metal or ammonium ion. Why are we saying ammonium ion? Ammonium ion, there we have ion. Ammonium ion is the only radical with a positive charge. Therefore, when it is reacting, when a base having ammonium is reacting with an acid, ammonium radical react like a metal. Very important. Name one other reagent which must be reacted with dilute sulfuric acid to form copper 2 sulfate. Any other? And now, here you need to understand very well. Our target is to identify one other reagent, any other reagent which must be reacted with dilute sulfuric acid. So meaning they have given us one reagent. We need to mention the other reagent. Now, this compound here is copper 2 sulfate. The compound we want to form is copper 2 sulfate. Remember, the sulfate will come from sulfuric acid because sulfuric acid is so called sulfuric because of the presence of a sulfate. Meaning, sulfuric acid will give us a sulfate. What is going to give us copper? It will be an insoluble base. And this insoluble base is called copper 2 oxide. Why are we going to use copper 2 oxide? Because copper 2 oxide will give us copper 2 sulfate. You have seen there, and I have put a 2 there. Copper 2 oxide. Once you say copper oxide, just know that you will fail. Because Copper is a transition element, and the transition elements are variable valences. So you should state the valence of a transition element you are using. So in this case, since we are preparing copper 2 sulfate, we need to use copper 2 oxide. Very important, my dear learners. Very, very important. Construct a balanced chemical equation for the reaction in B above. In B, where we have used copper 2 oxide and dilute sulfuric acid. So we are going to say, you understand that copper 2 oxide is an insoluble base. You remember, guys, all bases formed from transition elements are insoluble bases. So plus sulfuric acid in aqueous state. What is going to be formed? We are going to form copper 2 sulfate in aqueous state plus water in liquid state. This is our chemical equation. Now, the other part is balancing. We have copper 1, sulfate, balance radicals as radicals. So we have one sulfate, we have one sulfate. We have 2 hydrogen molecules or atoms, 2 hydrogen atoms, oxygen, oxygen. This equation is also balanced. So as I told you, you are going to tell the examiner that the equation was balanced by giving them a statement. The statement of proof which is going to guide them that you checked will be the equation balanced by inspection. Telling the examiner that you inspected the equation and it was already what is balanced. Very important, my dear learners. Going forward, describe briefly how a dry sample of copper 2 sulfate can be prepared from the named reagent in B, and you have 4 marks there. We have stated the state symbol of copper 2 sulfate, and the state symbol from the reaction is aqueous state. Now, how can you prepare the dry sample of copper 2 sulfate from the named reagent? Remember, my dear learners, our reagents are copper 2 oxide and dilute sulfuric acid. Now, when we prepare our product, copper 2 sulfate, we need to convert it to a solid so that we can meet their demand, because they are saying a dry sample, meaning we need to convert the aqueous copper 2 sulfate to solid copper 2 sulfate. What will be the procedure? That is what they are asking for. The first step, since copper 2 oxide is insoluble in water, it will be very difficult for copper 2 oxide to react easily with dilute sulfuric acid. Therefore, the first step you are going to do, you are going to warm sulfuric acid in the beaker. So we are going to say Just a minute. We are saying you warm sulfuric acid in a beaker. Point number 2, you are going to add copper to oxide while stirring until no more oxide dissolves. From here, since you are adding excess copper to oxide, you are going to filter the mixture to remove undissolved copper to oxide. From there, the second, the followed step will be you put the filtrate, put the filtrate on evaporating dish to remove excess water. From there, you are just going to remove excess water. You will remain with the small amount of water, and then you are going to cool the saturated solution to form crystals, and then dry. The crystals. So here we are saying when you form the solid crystals, you need to dry them so that you can remove some remained water on the surface of the solid crystals. And when you do that, it means you would have dried your prepared copper 2 sulfate. Very important. In this case, you are going to get your 4 marks. This is how we prepare copper 2 sulfate from insoluble bases. So not every time that they'll be asking you about copper 2 sulfate, they can ask you about magnesium sulfate. You should be able to follow the steps and answer questions. D. When we answer this question, it means we will be done with the question that came in 2013 from grade 11 topics. Will the method in part C above be suitable to prepare a sample of potassium chloride? Give a reason for your answer. Now, my dear learners, potassium chloride is a soluble salt which is prepared by titration, where we use a soluble base which is reacted with an acid. Now, potassium is very reactive, and when it is reacting, it is not possible that we can use heat so that we can facilitate the chemical reaction. It means now the reaction will be very explosive. Therefore, we cannot use, so we are going to say, the first mark will come from your response where you are going to say no. The reason is that because potassium is very reactive. Why are we saying potassium is very reactive? Potassium reacts explosively with acids. Therefore, we cannot use heat when we are using potassium, or we are using a base which contains potassium. That is very, very important. So you are going to have your 1 mark, and the other mark will come from your reason. Thank you so much, my dear learners. I promise that I am going to continue from where I have ended today, and that will be now answering questions from 2014 past papers. For now, I say good day and enjoy the rest of the day. Thank you so much. Don't forget to subscribe.